In this tutorial, we're going to go over binary subtraction using 2's complement. I'm sure at this stage we do already understand that a computer understands machine codes in zeros and ones, which we are referring to as what? Binary. Okay. So now, if you ever wondered how a computer gets to present a negative number, let's say a -7. Okay. So in every computer we have what we call registers, and these registers basically are the ones that helps us to represent our numbers in binary. So it can be a 6 register, it can be 8, it can be 9. Okay, what it implies is if you're given a number, we'll start by looking at the 7, the positive part or form of a 7, and we do convert that number 7 to binary by dividing by a 2. So what do we get to have? Let's see. Divide 7 by 2, you have 3, remainder 1. Again, you have, how many times can you divide 2 into 3? That's like 1, remainder 1. Again, you can divide the 2 into 1, where it's like 0 times, remainder 1. Now, given that you're talking about a 6 register computer, of course, each time you should add a 0 at the end, and then write your number going up. So we have 0, 1, 1, 1. Now, in a case where you're talking about a 6 register computer, so we would want to add 2 more zeros there to make it what? 6 numbers. So that is a 6 register computer. So this is representing or denoting what? 7, a positive 7. So if you want to prove that, you can now indicate them, right? So this is at position 0, right? So I'll write the 2's there to show my conversions from decimal to what? From decimal to, okay, we're moving from binary, sorry, to decimal. So try that. So you have 0, you have 1, you have 2, you have 3, you have 4, 5. So in this case, we're just basically interested in the one part that is adding ones, right? So 2 to the power 0 is what? I'll write them down. That's a 1, that's a 2, and that's a 4. So if you get to do your multiplication, 4 plus 2, 4 plus your addition, 4 plus 2 plus 1 is what? A 7. So this is basically the presentation of 7 in binary. Now, how do you get to present -7 on the other hand? So what you need to understand that in every case where you have 0 as preceding, it basically denotes a sign, right? So 0 denotes a positive sign. Whenever you start a number with a 1, we're going to consider it to be what? A negative in binary. So how do you get to present -7? So we can present -7 in a 6 register as what? Something coming out like this: 1, 0, 0. Then we have 1, 1, 1. So this number that is at the end there denotes what? Denotes a negative. Okay. So now, we are not interested in working with that kind of conversions. We need to convert now the -7 to what? To 2's complement, because that is the best way that we get to work with whenever we're dealing with what? Whenever we're dealing with subtractions. So how can we look at that then? So what we're going to have is something that is going to come out like this. So this is the 7. We consider a positive 7. We'll copy it the way it is. So we have 0, 0, 0, 1. So we're considering a 6 register kind of a register 6. Okay. So what do we have in this case? So we are going to take first of all the complement of the given numbers. That's the first step in your conversion. So you have 0, 0, 0. Why are we saying ones are becoming zeros? Because we do know that a computer is dealing with binary, right? So we only expect to have 2 possible results, a 1 and a 0. So if the complement of the 1 is 0, 1's complement are going to give us what? 1's, right? That's what we have. And then the other stage, or the next step that you need to consider, is now adding what? You need to add a 1 to give us what? To give us what we are looking for. So we have a 1, 0, 0, 1, 1, 1. So what you have in this case is what you are calling what? You've converted your 7, right? You've converted your 7 to what? To 2's complement, which is the study that we are focusing on in this video. Okay. So now let's try to perform the addition between our -7 and our positive 7, so that we get to see what we're going to have. Knowing that what we have here is already a positive 7, we can now add a negative 7. We see what we're going to have. So for negative 7, what do we have? So we have 1, 0, 0, 1, 1, 1, right? That's what we have. So we're trying to perform a sum of these two numbers, right? Let's see what we're going to have. 1 plus 1, that's giving us what? A 2, right? So first, we can't write a 2 because we're dealing with the binary. So we need to divide the 2 by what? A 2. 2 divided by 2 is going to give us 1, a remainder of 0. We always write the remainder. So we have a 0, we've carried the 1. 1 plus 0 is what? Is a 1. Plus the 1 that was carried gives us 2. Again, we'll do the same. The remainder will be 0, we'll carry the 1. Again, we'll do the same. We'll carry the 1. Again, we'll do the same. We'll carry the 1. We'll do the same. We'll carry a 1. We'll do the same. We'll carry a 1. And then at the end, we'll remain with a 1. And finally, we have a 1. So notice that the one at the end there just basically is not important because we are looking at a 6 register. Remember, we started with 6 register what? System. So if we need to just consider 6 first now, 6 numbers 1, 2, 3, 4, 5, and 6, implying that the addition of 7 and negative 7, of course using 2's complement, has given us what? Has given us a 0, which is true in the actual sense if you look at decimal kind of additions, right? Okay, let's try to move on. We've now looked at one example on how you get to convert a negative number to what? To 2's complement. Now, let's try to move on. How basically do you perform subtraction of these numbers? So first of all, we'll start by subtracting 23 minus 17. And then we'll move on and look at 26, subtract 15. And then we'll look at the issue of subtracting a bigger number, or we'll start first of all by 17, subtract by 23. And then we'll also look at the issue of subtracting negative numbers themselves. How do you get to look at these 4 different situations? So of course we're looking at 2's complements. Alright, so 23 minus 17. So I want to make sure that the numbers that we have first of all are converted to what? Are converted to binary. Of course we are interested in performing additions. So subtracting 17 is the same as adding a negative 17 to 23, right? Okay, so we have 23 to start with. So divide 23 by 2. It's going to be what? That's going to give us 11, right? Remainder what? 1. Again, divide the 11 by 2, you have a 5, remainder 1. Divide 5 by 2, you have 2, remainder 1. Divide 2 by 2, that's like 1, remainder what? 0. Divide 1 by 2, that's 0, and you have a 1, right? That's true. Okay, so you can then try that. 2 times 11, 22 plus 1, that is 23, 2, just and so on and so forth. You still get to have the same result. So what register are we considering in this case? We're considering a 6 register system to perform this operation. 6 register system. So this is what we have. I'll write it starting from down. So we have 1, 0, 1, 1, 1, right? Okay. What number are we presenting there? We're presenting 23. Okay. Now we are looking at a 6 register system. So how many digits do we have? We have 1, 2, 3, 4, 5, right? We have 5 numbers. So we can add one more, which will what we can add is what? Is a 0. So we are 6 now. Okay. We can now consider 17. We see what we're going to have. We are still converting it to decimal. So we have 17, right? Okay. So 17 divided by 2. Remember it's 8, right? 8 times 2, that is 16. So we have remainder 1. Then you have 4, remainder 0. You have 2, remainder 0. You have 1, remainder 0. You have 0, remainder 1. How many numbers do we have? Starting from down, we have 1, 3 zeros, and then a 1. So looking at a 6 register, 1, 2, 3, 4, 5. So add one more 0 to make it what? To make it 6. So that is our 17, a positive 17. Now we are not interested in looking at the 17. So we need to make sure that we convert this 17 to a negative form, finding negative 17. So also when we are going out what we are calling 2's complement. So we have 0, 1, 0, 0, 0, 1. So from the previous example, we had said whenever you're looking at that, first of all, one thing that you need to make sure is that first of all you need to find the complement of the ones, right? So 1 will become 0, all the zeros will become 1s, the 1 will become what? 0, and the 0 will become a 1. Then at this point you would want to add now a 1, right? To give you 2's complement. So you have 1, 1. So 0 plus 1 is the 1. Then 1 plus 1. How many 1s do we have? We have 3 1s, then 0, and then a 1. So this is your negative 17, right? So I'll show it down here. So we have 1, 1, 1, 1, 4 1s, a 0, and then a 1. So this is denoting negative 17 using 2's complement, right? So let's perform our operations there. We see what we're basically going to have as our result. So 1 plus 1 is going to give you what? So 1 plus 1 is going to give us a 2. We need to divide 2 by 2, giving us 1, a remainder of 0. So write the remainder 0. Then the next step, 1 plus 1, it's a 2, plus the 1 that was carried, gives us a 3. We'll still divide it by 2. Here it's 1, remainder 1. So write 1 and then carry 1. 1 plus 1 is a 2. Remember we carried a 1, so it will be now what? It will still be 3. So 1, remainder 1. Then we have 0 plus 1 is what? It's a 1. Plus the 1 that we carried, it gives us a 2. If you divide by 2, it will be 1, remainder 0. Write your remainder and carry the 1. 1 plus 0, again, will take us back to that. That is the 1, plus the 1 that we have just from carrying gives us what? It gives us a 2. So again, write 0 and then we'll carry a 1. Again, 1 plus 0, that's a 1. We've carried a 1, so it will still be 0 and then a 1. Okay. So remember we're looking at a 6 register. So we just consider the 6 numbers, right? So 1, 2, 3, 4, 5, 6. So the result that we have is 0, 0, 0, 1, 1, 0, right? Okay. So that is our result after performing the operations. Okay, so we've added our digits, that is 23 plus what? Negative 17. We've added them. Okay, so the number that is down here was denoting our negative 17, and this is our result. Now, is it true? Let's try to convert this number that we have to what we are calling what? To what we are calling the decimal form. So remember, this is at 2, that is at 4, that is at 8, 16, 32, 64. So we're interested in the part that you're having what? Ones. So 8 plus 4. So what do we have? Sorry, I needed not to start from 2. I'm supposed to start from 1. So we have 1, 2, 4, right? Okay, so that we just have addition of 4 plus 2, giving us what? A 6. And if you try to subtract or add 23 plus 17, your answer is what? Is a 6. So this is the result in a 6 register. Okay, so we've already talked about the part now where we are involving the addition of a negative number and a positive number. How else can we now subtract a smaller number by a bigger number? Now, in this case, we're talking about this kind of a form, right? So just make some changes there. We're not interested in the negative 17, and I already have my 17 converted to binary, which is the figure that is on top there, right? That is our 17 in binary, a positive one. So in this case, we are considering 17 minus 23, which is like 17 plus negative 23. So we can consider now converting this number to 2's complement so that we present our negative value. Okay. So first of all, we can convert to complement, 1 complement. So a complement of 1 is 0, 0, 0, 1, 0, 1, right? Then we need to convert to 2's complement by just adding a 1. So we have 1, 0, 1, 0, 0, 1, right? These numbers will be 6, and they are. Okay. So now, value now has changed to a negative 23 in 2's complement. So we have 1, 0, 0, We have a 1, a 0, and what? And a 1. So we can now perform our addition there to see the possible result that we need to expect to have, right? Okay, let's perform our addition there. 1 plus 1 is a 2. So we can't write a 2 divided by 2, giving us what? 1, remainder 0. So we'll consider our remainder 0, right? Then we'll carry the 1. 0 plus 0 is 0, plus the 1 that we've carried is a 1. 0 plus 0 is 0. 0 plus 1 is a 1. 1 plus 0 is a 1. 0 plus 1 is a 1. How many numbers do we have? We have 1, 2, 3, 4, 5, 6. Right. So we have 6 digits here. So this is our results now after performing the operations. Okay. Now remember, this is presenting a negative result, because if you look at 17 being subtracted by a 23, our result is basically a negative 6, right? Okay, which implies that this result is in 2's complement. So we want to convert it back to binary. How do you get to do that? How do you convert it to binary? So first of all, remember in our conversions, what we were starting with is the idea that, so let me write the operations that we are performing. 17 minus 23, which is a negative 6, right? So first of all, we were adding a 1. So now to reverse everything, or before you can even get to do that, the first thing that we are doing was first of all to perform a complement and then add a 1. So this time around, to reverse everything, we're going to start by subtracting a 1. So we have 1, 1, 1, 0, 1, 0. We need to subtract a 1. Remember, we are adding a 1, so we need to subtract a 1 to reverse everything. 0 minus 1, we can't, so we'll borrow from the next number, and then we'll have a 2 there. 2 minus a 1 is a 1. So then everything else remains as it is, 0, 0, 1, 1, 1, right? So we've subtracted the one that was added in the time of, at the time of converting to 2's prime, and then we need to perform a complement at this point. So this becomes 0, 1, 1, 0, 0, and a 0, right? Okay. So our 6 digits are these. So that is our result. And if you try to consider the positions, this is 1, 2, 4. Of course, we just consider where they are ones. So 4 plus 2 is what? It's a 6. Now negating it is a negative 6, which proves that indeed our answer is what? Is correct. Okay. So this is how you perform binary subtractions using 2's complement. And we've now talked about two different ways. A case where you're subtracting a bigger number from a smaller number, and vice versa. Okay, now we still have some more operations to perform. We've talked about 6 registers and we've done some operations there. Let's now consider looking at subtraction that we involved 23 and 29, right? So let's try to perform that. So we'll look at 23 minus 29. So I want to make sure that the numbers that we're looking at are supposed to be first of all in what? In binary. Okay. So we are adding, we are considering looking at what? Addition. So we have 23, right? So divide 23 by 2. What do you expect to have when you divide 23 by 2? So you have 11, right? And you have a remainder of a 1. You divide 11, that's like 5 times, you have a 1. That's like 2 times, you have a 1. That's like 1 time, you have a 0. That's like 0 times, and then you have a 1. Okay, I'll add a 0. So I have 0. We'll start from the bottom of 0, 1, 0, 1, 1, 1. And we're looking at the 8 registers this time around, okay? So we're considering a computer with 6 registers. So those are the places that we have to keep our numbers. So we have 0, 1, 0, 1. So I want to add some more zeros to make it 8. How many are these already? 1, 2, 3, 4, 5, 6. Also, I'll add 2 more digits to the left. 1 and 2. So what is our 23 in binary? Now we want to add a negative 29. So before that, let's convert our positive 29 to binary. 29 divided by 2. So it's like you're dividing 28 by 2, which you know is going to give you 14, right? so that is like 14, you have a remainder of a 1. 2 into 14, that is like 7, you have a remainder of what? 0. Divide your 7, you have a 3, and then remainder of what? Remainder of a 1. 3 again, if you divide your 3 there, you're going to have a 1, and remainder of a 1. Again, if you divide the 1, that's like 0 times, and the remainder of what? A 1, right? Is that true? Let's try to go back again. 29 divided by 2, that's 14 times, remainder 1. 7, remainder 0. That is like 3 times, remainder 1. That's like 0 times, okay, 1 time, remainder 1. And then 0 times, remainder 1. Okay, now there's 0 at the end. So what do we have? We have 0, 1, 1, 1, and then a 0, and then a 1. How many digits are these? So we have 1, 2, 3, 4, 5, 6, right? So we have 6 digits. Now we need to make it 8. Okay, but before that, remember this is our positive 29. So we're not interested in the 29. We're interested in what? We're interested in coming up with how many values? We're expected to have present our negative value. So let me add some 2 zeros here to make it 8. So 1, 2, 3, 4, 5, 6, 7, 8, right? So we have our 29 presented as what? As 8 registers. So now, how do we get to convert this number to what we are calling 2's complement? Because remember, it's a negative digit, and we don't want it to remain positive, so we want to convert it. Okay, let's do that. Okay, so the first thing that we need to do is, first of all, by negating the numbers that we have, right, which we are calling 1 complement. So we have 0, 1, 0, 0, 0, then we have 1, 1, 1, right? That's what we have. And then for our 2 prime, what are we going to have? So we need to add a 1 for us to get the final result. Okay, so adding a 1 to this number, what do we expect to have? So we just add a 1 there, and we just have like 1, 1, 0, 0, 0, 1, 1, 1, right? That's what we have in 2 prime, 2's complement. Okay, so now that's the number that we are going to now add to what we have. So what we are considering now is the negative 29. I can write the numbers. They're supposed to be 8. So we have a 1, 1, 3 zeros, and then we have, how many ones are those? So we have 3 ones. Okay, let me just write that again. Okay, so we have 1, 1, then 3 zeros. So I need to match up with that one. 0, 0, 0, 3 ones, right? So that's what we have, and this is denoting our negative 29 in 2's complement. Okay, let's perform our addition there. 2 plus 2, 1 plus 1, sorry, is like a 2. 2 divided by 2 is 1, remainder 1. Is that true? No. So it's 1, remainder 0. Okay. So write our remainder 0, and then we'll carry our 1. So 1 plus 1, it's a 2, plus the 1 that we've carried is a 3 over 2. So we have 1, remainder 1. So write the 1 and carry our 1. The next part is 1 plus 0. That's like 1. So remember, we are carrying a 1 from the other part. So we have a 2 again, which will now give us 1, remainder 0, right? So write the 0, and then we'll carry a 1. 0 plus 0 is 0, plus a 1 gives us a 1. Then we have 1 plus 0 is a 1. 1, 1, 1. How many numbers are these? They should be, how many numbers? Should be 8. So 1, 2, 3, 4, 5, 6, 7, 8. So this is our 8 register result. So remember, 23 minus 29 is what? Is giving us a minus 6. So now, is it true that the number that we have is denoting a negative 6? So you can try to do the conversions there. So the fact that our result is a negative, we need to convert this from 2's complement back to binary if you want to prove your solution or result. And something that we need to start with first of all is by subtracting the 1. Okay, so subtract 1. So subtract 1 from what we have. what do we expect to have? Okay, so let me just do something there. So we're subtracting a 1. Okay, so we can't subtract from 0. We can borrow from the next number, so that we have a 0 and then we have a 2 there. 2 minus 1 is a 1. Then we have 0, 0, 1, 1, 1, 1, 1, right? Of which I feel these are 8 figures already. Then at this point, we now want to negate everything that we have. We're just trying to reverse what we do when we are converting from binary to 2's complement. So negate that. You have a 0, 1, 1. You have 0, 0, 0, 0, and a 0, right? So that's the result that you have. And if you get to consider this number, it's like you have 0, 1, 1, right? Forget about all these other zeros in front. So if you consider this, you have 2. Start from 1. You have 1, you have 2, then you have 4. So if you get to consider them there, it's 4 plus 2, giving you a 6. You negate it, since we are coming from 2's complement. So we're presenting a negative result, a negative 6, which we've proven, which is true. Okay. Now let's look at another case where we're looking at a different form of a question, where we have now 2 negative numbers, right? 2 negative numbers. That is negative 31 and what? Negative 31, and then we have a minus 6, right? How do you get to add these numbers? So we can consider negative 31, and then we had a minus 6, right? So before anything, we want to make sure that the numbers that we're dealing with, first of all, are converted from binary, first of all, from the decimal form to the binary, and then from binary to 2's complement, right? So 31, start with 31 as a positive number. Divided 2 there, it's 15. The remainder 1. Into 15, that's like 7 times, remainder 1. Into 7, that's like 3 times, remainder 1. Into 3, that's like 1, and remainder 1. Into 1, sorry, you're dividing your 2 into the 1, that's like 0 times, and the remainder 1. Again, you get to do the same. You add a 0 at the end. So what registers are we looking at? We're looking at 8 registers as well. So we need to have 8 results, right? 8 numbers. So we have 0. How many ones? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Plus a 0. That is like 6. So 7 and 8. So what we are denoting is a positive 31, right? So we need to convert the 31 to what we're coding what? To what we are coding 2's complement. But before that, let's try to convert our 6 first of all to binary. So that's a 3, remainder 0. That's 1, remainder 1. That's 0, remainder 1, right? So what number do you have? You have 1, 1, 0. And since I'm looking at a 8 register, how many numbers do I need to add? 1, 2, 3. So we have 1, 2, 3, 4, 5, 6, 7, and 8. So let me just create some space. So we have 1, 1, 0, 4, 5, 6, 7, and 8, right? So this is our positive 6. So I want to convert these numbers to their 2's complement. So the first thing that we need to do is, first of all, negate everything that you have. So that is 0, 0, 0. How many ones do we have? We have 1, 2, 3, 4, 5. So we want to have 5 zeros. 1, 2, 3, 4, 5. And then we have 3 ones, right? Then for the other part, we do expect to have the same. So I have a 1, and then 2 zeros, and then 5 ones. 1, 2, 3, 4, 5, right? So these numbers are supposed to be 8. Okay. So now at this stage, we've just negated everything, which is like 1 prime. We need to take to 2 prime by, first of all, adding a 1, right? Add a 1 both sides. So for the 31, if you had a 1, what do you have? So you just have a 1 and then 4 zeros in between. 1, 2, 3, 4, and then 3 zeros at the end, right? 1, 2, 3. So these numbers 8, 1, 2, 3, 4, 5, 6, 7, 8. The other part, 1 plus 1 is like a 2. So you write, remainder is 0. If you divide by a 2, you carry a 1. So you have a 1. And then you have a 0. And then you have how many ones? 5 ones. 1, 2, 3, 4, 5. And then you have 8 digits as well. So this is denoting your negative 6. This is denoting your negative what? That's 1. So we've converted our numbers to what? To what we are calling 2's complement. So now we're trying to perform an addition of the 2 digits to see what we basically expect to have, right? So we have 1, 1. Let me just create some space. So we have 3 ones, 1, 2, 3. And then we have 4 zeros, 1, 2, 3, 4. And then we have a 1 at the end. That is denoting our negative 31. And then we have how many ones? 5 ones. 1, 2, 3, 4, 5. A 0, 1, and a 0 there. That's a minus 6. Let's try to perform our operations. We see what we're going to have. So what are we trying to do here? We're trying to add, right? 1 plus 0 is a 1. You have a 1, 0, 1, 1. Then 1 plus 1 is 2. Divided by 2, that's like 1 remainder 0. So write a 0. 1 plus 1 is a 2. Plus the 1 that was carried, 3. 3 over 2 is a 1 remainder 1. So write a 1 and then we'll carry 1. Again, 1 plus 1 is a 2 plus the 1 that we've carried is a 1. So again, we're considering a 1 that we had remained, right? So we have a 1. We are only interested in how many digits? 8 registers. So 1, 2, 3, 4, 5, 6, 7, 8. So this is our result. 1, 1, 0, 1. And then you have what? And then you have 1, 0, 1, 1, right? So this is what we have after performing our operations. Okay, so we've come to the end of our tutorial. You can try by converting this number back to binary. Okay, so why are we saying converting it back to binary? Because what we have is basically denoting a negative result, because negative 31 minus 6 is supposed to give us what? A minus 37. So try to converting this number back to binary and then converting it back to decimal to see if it's going to be equivalent to a minus 37. So thank you very much for taking time to watch this tutorial. I just hope that you now know how to convert from binary to 2's complement and vice versa. Thank you very much once more. Make sure to subscribe.